Let us discuss synchronous design. So, in this, we are going to deal the topic called synchronous timing basis. So, if you design a system, um, mostly it is of they use a clock or a periodic synchronous signal. So, therefore, the generation and the distribution of the clock it has a significant importance on the performance and power dissipation of the systems. So, what is timing analysis means that the timing analysis are done on any digital circuit in order to determine if the timing constraints are met. If you consider this pipeline data path circuits and timing parameters, let us discuss. This is my clock, and this is the rising edge of the clock. Okay, this is the time period is 2 nanosecond means how to determine this time period means the starting point of the rising edge of the clock and the completion of the rising edge of the clock. It denotes the one clock cycle. So this must be exactly equal, right? If it is 2 nanoseconds means in the ideal world, the phase of the clock at the various point of the system is exactly same. Since we are assuming the clock path is from the clock central distribution point to each of the resistors are perfectly balanced. Okay, so let us discuss what is TC, the timing parameters. This is a pipeline data path. It consists of two resistors, resistor 1 and resistor 2. So first, what is TCQ? Okay, TCQ is a maximum propagation delay of this resistor. Okay, this is nothing but a resistor. And TCQ CD. Okay, it represent this one represent minimum propagation delay of the resistor. So if you assume this is my clock period, and if I give D1 as my input, and it will reach the Q1 after some time period, right? So that does nothing but TCQ CD. That is a minimum propagation delay, and if you see this point is TCQ CD, and this one is T PCQ. It can be also written as TPCQ. Okay. This minimum propagation delay is also called as contamination delay, and this one is called as a maximum propagation delay. Or propagation delay. Of the resistor. Okay, so these are the two, and TSU represent the setup time, and T hold represent hold time of the resistor, and TCD. Okay, T logic. Okay, or TCD or TPD. Okay, TCD and TPD represent whenever the you can see after this one the D1 reaches Q1, it has to be processed by the combination circuit, this logic, right? So that is represented as TCD. So TCD represent the minimum delay, that is contamination delay of the combinational logic. Okay, the TCD represent minimum delay of the combinational logic circuit, or it's the minimum delay is called as contamination delay, right? Contamination delay. And what is TPD? TPD, it is also written as T logic. Okay, it's a maximum propagation delay of the combinational logic. Okay, so if I give the clock, okay, if I give the clock at the, if this point is I, okay, if this point is I, so this point is I, so the D1 will reach the Q1. Okay, the D1 will reach the Q1, and let me assume this point is J. Okay, this point is J. So during the J rising edge of the clock, this D1 will cross the have to cross the this cross this one, and it has to be processed by this combination circuit, and it has to be readily available during the rising edge of the J. Okay, so that is what I have represented here. Okay, that D1 has to process. So this is my I and this is my J. Okay, so the D1 has to so I can write this TC. Okay, TC is equal to T propagation delay of the register, that is TPCQ plus this TPD, right? That is the propagation delay of the combination logic, then plus setup time TSU of the setup time of the register. Okay, so I can write TPQ plus TPD plus T setup time is equal to TC. So if this is greater than TC, means what will happen? The data will be arrived late. Okay, so therefore I am going to make this the setup the TC value is greater than or equal to TPCQ plus TPD plus T setup time. Okay, so this T represent the minimum clock period. Why? Because if I want to find operating frequency, F is equal to 1 divided by T. So if I increases the T, okay, if I increase the T, the frequency will get reduced. So I have to keep it as a minimum clock period. So if this is T minimum means, okay, then only the frequency goes to maximum value. Okay, so next at the same time we are going to analyze the hold time of this resistor. So the hold time constraint is so if this is the next value, since it is passing this value, initially it is passing this value, X value, right? So if I am not holding the data, right, holding the data of this resistor and the combination circuits means D1 will be readily available during the rising edge of the clock at J. Okay, so therefore the whole constraint must be TCQ, okay, TCCQ, that is T contamination delay of the resistor plus the T contamination delay of the contamination delay of the combination circuit must be greater than or equal to it's not equal to greater than T hold. Okay. This is my hold time constraint. It is also called as minimum delay constraint. This is ideal when the clock is balanced. Okay, so if I use a different clock event that is turn out to be neither perfectly periodic nor perfectly simultaneous. So due to the environment variations, the clock signal can have both spatial and temporal variation, which lead to the performance degradation and the circuit malfunctions. So first let us discuss about clock skew. So this is due to spatial variation in the arrival time of the clock transition. So let us discuss. This is my clock. Okay, this is my clock 1, and this is my clock 2. Okay, so if you see this diagram, due to the delay in this path, the clock 1 will reach faster compared to the clock 2. So that is what I have represented here. The clock 1 will reach faster compared to the clock 2, and this rising edge I am given the name as 1, 3, 2 and 4. Okay, so the clock skew between these 2 points. Okay, the clock skew between the 2.1 and 2, I can write it as del, and del is equal to Ti minus Ti minus Tj. Okay, so where Ti represent the position of the rising edge of the clock with respect to reference, and the Tj represent the rising edge of the clock 2 with respect to reference. Okay, so due to the why this clock skew is caused means because of static mismatches in the clock path and differences in the clock. So this I can so my timing will get varied. So we know that T is greater than or equal to, that is T minimum or Tc, that is greater than or equal to T PD of the logic, right, plus TSU plus T. So this is what we have already discussed, right? T is greater than or equal to TSU, T logic and TCQ. Right. So now you can see if this is my T, okay, if this is my T or is T minimum, so it get extended by, since these two variation I can write it as del, right? So I can now it get changed to this one, I can write it as T minimum plus del. Okay, so I can write it as T minimum plus del. Okay, or it can be written as if this is coming this side means minus del you will get. So del greater than or 0, it represents positive clock skew. So you can see that the skew is constant from cycle to cycle, right? Because the del value is same. right? The del value, if Ta and Tj value is fixed, it means it will be fixed for entire cycle. This value is also del. If this is 2 means this is also 2. Okay, so it will be constant over the entire from cycle to cycle, and it happens due to the phase shift. Okay, so because of this, what will happen means, so if you see, the timing get increased. So if the timing get increased means, um, we can have the we can get more. Uh, uh, this will improve the performance of the circuit, right? Um, so the clock skew get increases the performance of the circuit, because it can take more time to process this this data and this one, right? That is it can take more time. Okay, so there will be no problem if I increases increases the del value, right? But it may be susceptible to race condition. Okay, this positive skew increases the throughput of the circuit. Okay, there is no problem with the setup time, but it will causes a problem in the hold time, right? So if I am not maintaining the hold time constraint properly, means it will causes a big problem. Okay, so for the positive skew, there is no problem with the setup time. There is no violation in the setup time, but it will causes a violation in the hold time. Okay, so for hold time, I can write it as so T hold, right? T hold is greater than equal to, greater than TC TCD of logic, right? Plus TCQ of logic. Okay, this is what I have written here, and TCCQ plus TCD, like logic, and this is of register, right? TCCQ of register. TCD of logic and TCCQ of TCCQ. Okay, plus del. Enter. So for the positive skew, there is no setup time violation. But it will cause us a hold time violation. So we have to satisfy this condition. Okay, so if we violate this condition, it will result in a race problem. Okay, so next let me go for the negative skew. So this is a block diagram of the negative skew. You can see the TC, the T clock 1 is delayed when compared to TC2. So this is my diagram, and you can write this is 1. Okay, so this is This is T clock. If this is T clock means what will be this one? So this is nothing but del, right? This is nothing but my del. So from here to here, I can write it as one. And this one is something about del, and this is also del, right? This is also del. So I can write from here. So from here to this one. What does this? And this I can write it as T clock plus del. Okay. From here to here. Again, T clock plus del. So this is the first edge, this is the third edge, and this is the second one, and this one is the fourth one. So if you see here, the del value is less than 0. So if del value is less than 0 means there is no problem with the hold time. No problem with hold time. That is the clock edges arrive even before the clock 1. So it has a limited time for the data D1 to process by this resistor and the combination circuit. So therefore it will cause us a problem in the setup time violation. It will cause us setup time violation. It will cause this negative skew. It causes setup time violation, and there is no problem with the hold time violation. So since there is no problem with the hold time, it provides greater immunity to race, right? If the hold time is 0 or negative. But it will cause us a problem with setup time. So therefore the routing the clock in the opposite direction of the data, so avoid disasters, but hampers the circuit performance. Okay. So we have to ensure that setup time violation should not get happen. Okay.